Okay, good evening. This is Professor David Delos Reyes. Okay, the date for today is November 1, 2023, and the time is around 8:14 p.m. My topic for tonight will be a continuation of my subject matter. It's only long video format, trigonometry, and we are now on lesson number 16. And the topic is logarithms. Okay, let's proceed. Subject matter for tonight will be trigonometry, lesson number 16. And the subject matter is logarithms. Okay, under the study of algebra, we have some logarithm topics over there. And still, under the study of trigonometry, we still discuss logarithms. Because in the solution of the so-called right triangle problems, okay, we use logarithms. So it's a must that we should know how to get the common logarithm, most especially for the natural logarithm. This will now be most especially used in the so-called higher up subjects. But under the study of trigonometry, okay, common logarithm is actually the common solution for problems involving right triangles. Okay, let's try to discuss. So it seems it's just we are having a review now because we have discussed already under the study of algebra and under the study of trigonometry. Again, we will be repeating some. So it's just like a review. So before we could perform some problems on the logarithm, so we should know what is a logarithm. It should be the definition of a logarithm. A logarithm of a number is the power to which the base must be raised to equal that number. That's the definition of logarithm. If you could memorize that one, you will not get lost in the study of logarithm. Okay, there are two types of logarithm. For the meantime, we will concentrate on the common logarithm and the natural logarithm. There are problems under the study of logarithm in which the base is not actually equal to 10 or not equal to a or just simply a. The designation is just simply a because a as a base could take any value. It could be the value 10 or it could be the value e. But the concentration of the subject matter for tonight will be the base 10 and the base e. Okay, the first type of logarithm, we call it common logarithm or common log. If we say the logarithm to be a common log, the base is actually equal to 10. And if we write that in terms of what they call this an equivalence, if the base is 10, it will be written like this. The logarithm with the base of 10. This 10 here is below the logarithm value. Okay, it is below. It is not in line. So we read this, the logarithm with the base of 10. And for it to be equal to common logarithm, the preferred way under common logarithm is simply just the log thing without the base. So from now on, if you see a log without any base placed on it, it is understood to be common logarithm. So under the common logarithm, we read this one, logarithm with the base of 10 is just equal to the logarithm. Simple like that. If there is no 10 over here, it is understood that the base is 10. Okay, that's the, what you call this standard notation for common logarithm. Okay, I will repeat it. The common log with the base of 10 is just simply log. No 10 here, it is understood that the base is 10 and this is under common log. Next one, natural log. The base of the natural logarithm is actually e, symbol e, the one on the calculator, e. small letter e. And the value of this, if you reach higher mathematics, actually we could derive this value here. When I brought out my topics on advanced mathematics, I derived the value of e by using, I think, a Taylor series or Maclaurin series of expansion. Okay, we were able to derive this value here. For natural logarithm, the base is actually e, and the value is 2.718, 281, 828. Oh, just display one here. E to the x is on the second function, so second function e to the x. Oh, this is the value of e. 2.718, 281, 281, 828. Okay, that's the value. And the proper way on how to write natural logarithm is actually log with the base e equal to. Again, we simplify the writing of natural logarithm. If under the common logarithm, we just write log. Under the natural logarithm, we will just place ln. But don't see ln because the proper way on how to read this one is natural log. Oh, you can see ln, but at least you know that ln is a natural logarithm, right? So for simplicity, under common log, we just write it as simply log. And under natural log, we just write it as simply ln or natural log. So at least we now know how to differentiate in the way we read the logarithm. If it's just simply log, it is common logarithm. It is if it is ln, it means it's natural logarithm. Okay, I will try to write the definition of logarithm in terms of an equation. It will be something like this. The logarithm of x with the base of a is equal to n. Or try to remember this one. Okay? The proper way how to read this one is the logarithm of x with the base a should be equal to n. Okay? This one is to be correct. Okay? If e to the n is equal to x. This one actually emanates from this. Because according to this, the logarithm of x with the base of a is equal to n. For this to be correct, okay, e to the n should be equal to x. Because this one here is actually the definition of the logarithm. It is the power to which the base must be raised to equal that number. That number n is actually the power of the base. If you get the base of the logarithm, raise that to power n, okay, and this should be equal to x. And that's the definition of logarithm. It is the power to which the base must be raised to equal that number. The power is actually the logarithm of the number. The logarithm of a number is the power to which the base must be raised to equal that number. The number we are referring here is actually x. Okay? The logarithm of a number is the power to which the base must be raised to equal that number. That's the definition of logarithm. Okay? If you know this one, you could derive this one. So wherever you go, you know what's logarithm. Okay? Where this capital letter N is actually the logarithm of the number. X is the number. We are the number in which we are taking the logarithm. And A is actually the base. Okay, this is a general equation. That's why I place it here. A is actually the base. And it could either take the value 10 or E. Okay? It could take any value. It's either 10 or E. So it could either be a common logarithm or a natural logarithm. Okay, let's try to bring out the parts of a common logarithm. There are parts of a common logarithm. I think we have not discussed this one under algebra, but under the study of trigonometry, I will be bringing out the parts of a common logarithm. Because if we try to get a logarithm of a number, there is the so-called whole number part, and there is the decimal part. And there is a name for that one. Okay? So for the parts of common logarithm, there are two parts, the characteristic and the mantissa. Characteristic is the so-called whole number part. It's either plus or minus, meaning the sign could either be plus or minus. And for the mantissa, it is the decimal part of the logarithm. I will try to give you an example. Supposing I display 25 here, and I will try to take the logarithm of this common logarithm. The common logarithm is 1.3979. 25. If I will try to take the logarithm of this, it should be 1.25 common log 1.397 940 009. Okay, this is the logarithm of 25. There is a number 1 there, and there is the decimal part there. This whole number part here is actually the characteristic, and this decimal part here, okay, is actually the mantissa. Okay, so from the value 1.397 940 009, the whole number part, which is 1, is actually referred to as the characteristic. And the number which contains a decimal number, the decimal part, 0.397940009, we call it the mantissa. I don't know if you have encountered this one under the study of algebra, but now since we are again studying logarithms under the study of trigonometry, I brought out already the parts of the common logarithm. It is the so-called characteristic in the mantissa. Characteristic is the so-called whole number part, in which the sign could either be plus or minus. And for the mantissa, it's the decimal part of the logarithm. Okay? 1.397 940 009. So this one is the characteristic and this one is the mantissa. Even without using the calculator, for me, I could determine that the characteristic of 25 is 1. Because in here, I will try to bring out the secret on how to determine the characteristic. The characteristic is actually the total number of integral parts emanating from, starting from the decimal point. Okay? Minus 1. Okay? 25 can be written as 25.0, right? Okay? So there is a decimal here. No number here, but we could place it as a 0.0, right? So to determine the characteristic of 25, just count the number of significant figures to the left, starting with the decimal number. So this is 1 is 2, okay? So the number of places going to the left is 2 minus 1. 2 minus 1 is 1. So in here, the characteristic of 25 is actually 1. That's why it is 1. Right? You got it? You now know why this is 1. So even without using my calculator, I know that the characteristic of 25 will be 1. Okay? It is actually 1, 2, it's 2. The number of places to the left of the decimal is 2, minus 1, and they should be equal to 1. So the characteristic of 25 will be 1. So this is 1. Without using calculator. Okay? Oh, what's next? The laws of characteristic. Laws of characteristic meaning the characteristic got some variations, okay? Characteristic of number greater than 1 is positive. Meaning to say, if a number is greater than 1, the characteristic is actually positive. It's a positive value. As long as a number is greater than 1, the characteristic is a positive number. That's the meaning of it. Okay, I am just bringing out the limitations of the quad list characteristic. How characteristic will come out. So at least we know if the number we are using is actually the correct one or not. Okay, it is equal to the number of integral places in the number less than 1. That's the one I'm saying. To determine the, what you call this, value of the characteristic equal to the number of integral places in the number less than 1. So starting with the decimal number here, okay, count the number of significant figure to the left. It's 2, right? Minus 1, that's the meaning of this. Whatever number you count, if it's 3, you subtract 1 and the characteristic will be 2. If you count 4, minus 1, the characteristic will be 3. That's the meaning of this. Okay? I will try to bring out some, what you call this, special cases under the study of logarithm. Actually, we have done this one already under the study of algebra. The common logarithm of 1, where the base of 10 is equal to 0, since 10 to the 0 is equal to 1. Right? We should know this one. The common logarithm of 1 with the base of 10 is 0, and the natural log of 1 with the base of e is still 0, since e to the 0 is equal to 1. We should know this one by heart. Okay? No matter what we are doing, at least we know that the common logarithm of 1 is 0, and the natural logarithm of 1 is also 0. Okay, let's try to bring out an example problem on how to bring out the correct characteristic in Mantis of a number. The given number here is, I will try to give you a number here. Okay, I will try to erase this one. So even without using your calculator, you could specify the characteristic of a number even without using the calculator. Of course, the mantisa, you could not bring it out without using the calculator, but for the characteristic, by using these laws of characteristic here, it is equal to the number of integral places in the number less than 1. By using this, you could determine the characteristic of any number. Okay, the example for tonight will be this. Find the characteristic in mantisa. The number is 1, 2, 3, and its logarithm, common logarithm. Meaning to say, we are asked to find the common log of 1, 2, 3 equal to, and we must have to specify what will be the characteristic and what will be the mantisa. Because the part of the logarithm is actually the characteristic in mantisa. Okay, for the characteristic, even without using the calculator, I could bring it out. 1, 2, 3 can be written as 1, 2, 3.0, because the reference point is actually the decimal point, right? 1, 2, 3 can be written as 1, 2, 3.0. So starting from the decimal point, count the number of places to the left. Okay, how many numbers? It's 1, 2, 3. It is 3, right? And according to the characteristic, if we subtract 1, that will be the number of characteristic. 3 minus 1 will be 2. Okay, that's why the characteristic of the logarithm of 1, 2, 3 is 2. That's the reason why it is 2. It is this. Right? But how about the mantisa? We cannot do anything about it. We must have to plug in the number on the calculator to get the decimal part. Okay, 1, 2, 3, common log. The characteristic here is 2. It's really 2, right? Okay, and the decimal part is 0.089905.111. This is the mantisa. mantissa. Right? It's the number from the decimal point to the right. Meaning it is not, it is just a decimal part. We call it the decimal part. The mantissa is just a decimal part. But for the characteristic, like what I said, even without using the calculator, I could determine the characteristic of 1, 2, 3, it's 2. And the decimal part or the mantissa is 0.08990511. Oh, that's how it works. I don't know if we have discussed characteristic and mantissa under the study of algebra. But under the study of trigonometry, I will now bring out this one because it's a needed thing that we should know what is characteristic in mantissa if we are talking logarithm. Okay? One example, simple problem is the logarithm of 1000 with the base of 10. 100. 100 can be written as 100.0, right? So if we try to bring out the characteristic of the logarithm of 100, the number of places to, number of significant figures to the left of the decimal is actually 3. This is 1, 2, 3. So the characteristic of 100, if we try to take the logarithm, it should be 3 minus 1, and this should be equal to 2. The characteristic will be 2, so this is 2, right? And if you try to punch 100 over here, oh, just simply 100. What comes out is just a pure characteristic, right? Meaning to say the mantissa part of the logarithm of 100 is 0. So it is actually 2.000 or just simply 2. Right? That's it. The characteristic is 2 because it is 3 minus 2, which is 3 minus 1 is 2. So the characteristic is 2 and the mantissa is actually 0. So this is actually 2.000 or just simply 2. Okay? That's why I place it here for the logarithm, common logarithm of 100 with the base of 10. The characteristic will be 3 minus 1, which is 2, and the mantissa will be 0. So the logarithm of 100 with the base of 10 is actually 2. Okay, as simple as that one, by using this concept here. How about 1000? 1000 can be written as, how could we write 1000, including the decimal number? 1000 can be written as, okay, it should be 1000 like that. Then we place a decimal here, then 0. So to determine the logarithm of the 1000 with the base of 10, we count the number of significant figures to the left of the decimal. It is 1, 2, 3, 4. So the characteristic now will be equal to 4 minus 1, and this should be equal to 3. So the characteristic of the common logarithm of 1000 is actually 3, right? And the mantissa is also equal to 0. So this is 3.000, or just simply the common logarithm of 1000 with the base of 10 is just simply 3. So, okay. So this 3 here emanates from this. Okay. So by using these concepts here, we could determine the characteristic of any number. Okay. It should be the number of significant numbers to the left of the decimal. You subtract it by 1. That is according to this. That's why I brought out this concept here. The characteristic will be the significant figure to the left of the decimal minus 1. So it will, for 1000, it will be 4 minus 1, and that will be 3. Okay, so this is 3. Okay, the logarithm of 1000 now with the base of 10 will be 3, and the mantissa is 0. You can't do anything about it. It's 3.000, or just simply the logarithm of 1000 with the base of 10 will be 3. Okay, that's it, guys. This is now what you call this. It seems we are having a review on logarithms, but regarding characteristic mantissa, we have not discussed this under the study of algebra. So for tonight, okay, that's an additional knowledge. Okay, good evening from Los Angeles, Professor David.